All right, so we're going to do our Unit 8, Lesson 1. We're going to talk about how to find the average value of integrals for functions. So we have our mean value theorem that works for integrals, and it has to be a continuous function on the closed interval from a to b. And if it is, then there exists a number c in the closed interval such that the integral from a to b of f of x dx equals our function f of c times our b minus our a value. So what that means is that's going to find the average value underneath the curve by finding a rectangle, and that rectangle kind of outweighs the overestimate from one side maybe, and the overestimate on the other side. And the under and the over end up zeroing each other out, and we get a correct, accurate approximation. And it's just saying that there is just a C value where that exists. It might be here in this case, it could be more to the right. But our mean value theorem does not find it. It just provides the fact that it does exist. So looking at our average value of a function, we would take the antiderivative or the integral from a to b f of x dx and then multiply it by 1 over b minus a in front. So what that's doing is we're taking the area underneath the curve and we're dividing it by the width of our intervals, or of our entire interval, whether it's time or whatever it is, whatever that x value is. And then we end up with f of c, which is our average height. All right, so let's go ahead and use this and practice what we just talked about. So for example 1, it says find the average height of f on the interval from 1 to 4, and we're given the function f of x. So average means I'm going to take 1 over the 4 minus the 1, since a is 1 and 4 is b. And I'm going to take the integral from 1 to 4 as well, of 3x squared minus 2x dx, or all with respect to x. All right, so I get 1 over 3, or 1/3, for my fraction out front. 3x squared, the antiderivative would be x cubed. The antiderivative of negative 2x would be negative x squared. And I'm going to evaluate that from 1 to 4. So when I substitute in 4, let's see, so that's going to be 4 cubed, so that's 64, minus 4 squared, so 16. All of that minus. Now when I substitute in 1, I get 1 minus 1, so it's going to be 0. 64 minus 16 is 48, so then 48 times 1/3 would end up being 16. So this would be 1/4, not one. Oops, it is 1/3. Goodness, I changed it to a 4 somewhere. 1/3, there we go, times 48, which equals 16 as our final answer. So the average value of f on the interval from 1 to 4 is 16. Okay. Find the value or values of c guaranteed by the mean value theorem for the integrals. So the mean value theorem guarantees that there is a value c because we do have a continuous function. This is a polynomial, and polynomials are continuous on all real numbers. So we want to algebraically, and with our calculus, find the c values that exist. So let's start with the fact that our mean value theorem guarantees that we have a value from 1 to 4 of f of x dx, and that's supposed to equal f of c times 4 minus 1, which I can rewrite this. I can take this and divide both sides by it, bring it in front. So now it's 1 over 4 minus 1. Integral of 1 to 4, 3x squared minus 2x with respect to x, and that equals my f of c. Now we just found this, right? We just found this on letter A. We found that that equals 16. So I know that f of c has to equal 16 somewhere. Now let's find where that somewhere is. So we're going to set f of c, which means we're just going to substitute all of the x's out for c in the function of f of x up above. So f of c is going to equal 16. We're going to solve for where that happens at. So instead of 3x squared, it's 3c squared minus 2c. Now let's go ahead and solve this. All right, so I'm going to subtract my 16 to the other side to get this equal to 0. Now you can either use grouping or bottoms up method. I'm going to use bottoms up. So I'm going to multiply my 3 to my 16. So that's going to be a negative 48. So I'm multiplying to get negative 48 and adding to get negative 2. So that's negative 8 and a positive 6. Now I have to divide both of these factors by 3, which means my two c values, where my function will equal 16, is 8 over 3 and negative 2, which negative 2 is not on my interval. I only go from 1 to 4. So that means my c value, where f of c equals my average value of my function, is 8/3. So I'll put therefore c equals 8 over 3 as my final answer. Okay, number 2. This one we're going to need a calculator for, so hopefully you have your calculator. I'm going to go ahead and write out everything I would put in my calculator as we go along. This says in 2000, the world's population was 6.1 billion, which I can see in this function here. And the relative rate of growth was 1.4% per year. You can see that as the exponent here. This can be modeled by our function n of t, where n is people in billions. That's important for our labeling. We have billions of people. And t is the number of years since 2000. Now, assuming the model remains true until 2050, find the average population of the world between the years of 2010 and 2020. What are the units? Okay. So we're doing average population. So that means average. So 1 over, we're going to do the years after 2000. So 20 minus 10. And then it's going to be the integral from 10 to 20 of my function n of t dt. And my calculator, of course, I can't just write n of t dt. So in my calculator, I'd say 1 over 10, 10 to 20, and then type everything in. 6.1 e to the 0.014 t with respect to t. So go ahead, type that in your calculator. Once you do, you should get, let's see, 7.5315. So what are the units? Well, this means the average population between 2010 to 2020 was 7.531 billion people. So billion people are our units. Okay, number 3, suppose that C of t represents the daily cost for air conditioning your house in dollars per day, or dollars per day, where t is the time in days and t equals 0 corresponds to July 1st, 2017. Explain what the following expressions represent in real-world terms, including the units. We don't need a calculator for this. I don't know why there's a calculator icon. All right, so let's see. So if I have just the integral from 0 to 90 of c of t dt, so this is actually going to be the total cost. And so this is from 0 to 90 days. So the total cost to air condition the house of AC in the house from, we'll say the starting date was July, well, it's 2017 to September 2017. So then when we take the average, when we put that 1 over 90 minus 0, we're taking the average. This is the average daily cost. So this is the average daily cost, because we're dividing by the amount of days right here. So the average daily cost in specifically dollars per day to cool the house between, again, we'll mention July to September. Okay. So anytime we have average, that means we're going to be talking about some kind of average. In this case, our daily cost, which they told us up here, dollars per day. So we knew it was daily. If we don't have that fraction in front, then it's just the total of whatever we're talking about, which in this case, we're talking about the cost of something, so total cost. All right, example 4, last example, we have the supersonic man. Chuck Yeager flew his rocket plane at an altitude of 12.8 kilometers. He was clocked at 299.5 meters per second, which is about 669.962 miles per hour. At different altitudes, sound travels at different speeds. We can model this variation for speed of sound with a piecewise defined function given below. This is all true, and data can be found using that link. For A, it wants us to integrate the function s of t over the intervals from 0 to 80 for the 5 sub-intervals. All right, so this is going to be interesting because we have 5 sub-intervals, 0 to 80, if you notice over here on our piecewise. So I'm going to write it all out, and then I'm going to use my calculator, even though it doesn't say calculator active, I think, but that calculator from 3 is supposed to be on this one. So I'm going to label this A down here. So let's start with our first piece of our piecewise. So let's see, I'm going to label my work 0 to 80, s of t dt would equal. We're going to start with our first integral from 0 to 11.5, and that is our piece of negative 4t plus 341 with respect to t. Plus, now our next piece goes from 11.5 to 22 seconds, and that's just a constant of 295 dt. Our next piece starts at 22 seconds and goes to 32 seconds, and that's going to be 0.75 t plus 278.5 with respect to t. Okay, I'm going to jump down to my next line, so plus. Now we're going from, we stopped at 32, so 32 seconds to 50 seconds. And we've got 1.5 t plus 254.5 with respect to t. Now my last interval from 50 to 80. That would be a negative 1.5 t plus 404.5 with respect to t. Okay, so I'm going to start to use my calculator. I'm going to do each of these integrals piece by piece, and then write them out so I can add them together. So if you want to pause here and see if you get the same answers in your calculator, it would help you make sure that you know how to use that calculator. All right, our first piece, we should have a total of 3,657. The second piece of our function from 11.5 to 22 seconds, we'd have a total of 30,097.5. Our third piece, we'd have 2,987.5. Our fourth piece, we have 5,688. And that fourth piece, we have 9,210. All right, so now when I combine all of that together, again using my calculator, I would get a grand total of 24,640. Okay, so what that means is that's the total distance that we traveled. We traveled 24,640 meters. Now, if I want to know the average, because part B tells me to apply the mean value theorem for integrals to find the average speed of sound, then I would take, say B, I would take my average from 1, oops, it's not a straight line, 1 over 80 minus 0, so obviously it's just going to be 80, of the integral, which we just found, 0 to 80 s of t dt, which would end up being my 24,640 over 80, which would give me a grand total speed, or my average speed, of 308 meters per second. And if I wanted to know what this was in miles per hour, because that's what they told us in the beginning, it's approximately 688.976 miles per hour, which relates back to what they told us in the question. We're not too far off of that 669.962 that was calculated. All right, we'll talk more about this in class and how we can use these averages to benefit us.